Hello, we are going to be going through your quarter 3 benchmark review. So the first set of questions that we have here are equations and inequalities. So remember, whenever you are solving an equation or an inequality, you are trying to get the variable by itself. And your first step is to always simplify, but in this case, number one, we don't have to. So your first step that you want to do is to always move the constant that's on the same side as x, and you're going to move it by doing the inverse operation. So since this is adding 12, the opposite of adding 12 is subtracting 12. Okay, so our plus 12 minus 12 are going to cancel. Over here for the result, we're going to be left with 3x equals. And then in our calculator, we can take negative 75 minus 12, and we get negative 87. All right, so we still need to get x by itself by removing the 3. So since the 3 and the x are currently multiplying, the opposite of multiplying is dividing. So negative 87 divided by 3 gives us an answer of negative 29. And remember, we can always check our work by plugging our answer back into the original equation into x by substituting it in, and then we can just do a mental check to make sure that it works. So I'm going to plug negative 29 back in for x and rewrite the equation. So then if I were to simplify this, 3 times negative 29 is negative 87. And then negative 87 plus 12 will give me that negative 75, so I know I did it correctly. All right, number 2, now this time I can simplify first because I see parentheses. If you can't do anything on the inside, that's when you move to the outside, and a number shoved up next to parentheses means that you're multiplying. Just remember that you're multiplying that outside number times everything on the inside, okay? So negative 6 times x is negative 6x. Negative 6 times a positive 8 is a negative 48. And then all of that will equal 96. So now I just have a basic two-step equation, so I can just solve like normal. So I'm going to move the constant that's on the same side as x first. The opposite of subtracting 48 is adding 48. So we're left with, because those cancel, we're left with negative 6x equals, and then 96 plus 48 is 144. And then our last step to get x by itself is to divide by that negative 6 on both sides. So then 144 divided by negative 6 is a negative 24. And again, you can check your work by plugging your answer back into the original equation for x and then just solving it to see if it works out. So following PEMDAS rules, I have to do what's inside the parentheses first. So negative 24 plus 8 is negative 16. And then if you were to take negative 16 times a negative 6, you do get that positive 96. So we know we did it correctly. All right, now moving on to inequalities. So you're solving an inequality the same exact way as solving an equation. The only thing that's different is instead of an equal sign, you now just have an inequality symbol. So let's go ahead and start solving. So for this one, again, if I'm trying to get x by itself, I need to move the constant that's on the same side as x over to the other side. So the constant here is plus 10. So the opposite of adding 10 is subtracting 10. And our result will be left with negative 5x. It's not an equal sign anymore. We're just going to drop down the greater than or equal sign. And 90 minus 10 is 80. And then our last step to get x by itself is to divide by this negative 5 on both sides. Now, here's the kicker with inequalities. If you guys remember, as soon as you see that you just divided or multiplied by a negative number, you must flip the sign. So when I say you must flip the sign, you must flip the inequality sign. Okay, so we divided by a negative number on both sides. So our greater than or equal to sign now turns into a less than or equal to sign. Okay, so that's just the only kicker that you must remember is when you multiply or divide by a negative, you have to flip your sign. Okay, but after that, you just solve it like normal. So then 80 divided by negative 5 gives us, I hit times, 80 divided by negative 5 is a negative 16. Okay, and instead of checking it, we have you guys graph your answer. So whatever answer you get, that's going to be your middle number on your number line. And then you just have to fill in one number to the right of that number on the number line and one number to the left. Remember that if you have the equal to line, that means that it can equal negative 16. So you're going to have a closed circle at negative 16. And then if we want all numbers less than or equal to negative 16, you're just going to point your arrow to the right, or sorry, to the left. Because all numbers less than negative 16 are negative 17, negative 18, negative 19, and so on. So any number that we plug in that's to the left of negative 16 on the number line would make that statement true. Okay, and then moving to number 4. So again, to get x by itself, I have to get rid of the constant on the same side first. So the first step, since it's subtracting 25, the opposite of subtracting is adding 25 to both sides. So we're going to be left with x over 2 is less than, and then negative 17 plus 25 is 8. And then to get x by itself, I got to get rid of that 2. So since it's dividing by 2, the opposite of dividing is multiplying. So I'm going to multiply by 2 on both sides. And we are going to be left with x is less than 16. Okay, so let's graph it. So 16 was our answer, so that's our middle number. One number to the right would be 17, and one number to the left would be 15 on the number line. Notice here how it doesn't have the equal to line, so that means that it cannot equal 16, which means we should have an open circle at 16. And then if we want all numbers less than 16, all numbers less than 16 would be to the left of it. All right, moving on to number 5. So number 5, identify all equations that have an equivalent solution to 3x minus 12 equals 24. So if we're looking for equivalent solutions, that means we need the same answer that we get to this equation for it to equal all of these equations as well. So there's a couple different ways we can do it. First thing though is we have to solve for x for this equation. So to get x by itself, the opposite of subtracting 12 is adding 12. We get 3x equals 36. And then last step is to divide by that 3 on both sides, and we would get x equals 12. Okay? So a couple of things we can do. We can solve each of these equations to see if you get the same answer as what we did up here. Or what you can do is you can just substitute 12 into x into all of these equations to see if it makes a true statement or not. If it makes a true statement, that means that 12 is your answer to that question. If it doesn't make it true, then that means that 12 is not your answer. So for example, if I plug in 12 for x here, I can just take 15 times 12, that's 180, minus the 60, and notice how I got 120, which is what they wanted. So that means that 12 was a solution to that equation. So let's try this one, 3 times x. So if we want it to equal 12, take 3 times 12, which is 36. So does 36 equal 12? Nope, so it's not B. Next one, just plug in 12 for x, and then take that minus 4. And does that equal what we wanted it to? Yep, so C is one of them. And then the last one, take the 12 times the 12, and then minus 12. And does that equal the same thing, 132 and 24? No, so your only two solutions are A and C. All right, number 6, which number line shows the solution to the inequality? So let's solve this first. So to get x by itself, first number I need to move is the 5, and since it's subtracting, the opposite of subtracting is adding. So we're left with negative 3x is less than negative 2 plus 5 is 3. And then our last step to get x by itself is to divide by that negative 3 on both sides. Again, guys, as soon as you see that you just divided by a negative, what do? We must flip the sign. So our less than sign turns into a greater than sign, and then 3 divided by -3 is -1. So we need the graph that would be equivalent to x is greater than -1. So the first thing that I notice is that there's no equal to line on our inequality symbol. So that means that I must have an open circle. So over here, I notice that the only two options that I have for open circles are A and C. So that means that B and D are not going to be the answers. Then I need all numbers greater than -1. So all numbers greater than -1 are to the right of it. So I need an arrow pointing to the right, which in this case is going to be A. So A is our answer. All right, number 7. So find the area of the given circle. So remember, our area formula is pi r squared. They want us to use 3.14 for pi. So your substitution line, you're going to plug in 3.14 for pi. R stands for radius. Remember, the radius is half of the distance of the center of the circle. So they do give us that radius, which is 5. And then we're going to square it. Then I'm just going to plug this in my calculator. So following PEMDAS rules, we have to take 5 squared first. So 5 times 5, which is 25. Then take it times your 3.14, and we get an answer of 78.5. And remember, since we were finding area, area is always squared, so our unit is going to be centimeters squared. All right, number 8, so now we're finding circumference. So remember, area is talking about the amount of space on the inside of the circle. Circumference is talking about the amount of space on the outside, so in other words, the perimeter. So we have 2 circumference formulas. It doesn't matter which one you use, just make sure you plug in the right numbers for it. Since looking at the circle here, they give us the diameter of the circle, I'm going to use the formula that has diameter in it, which is just the circumference equals pi d. You can use the 2 pi r formula, just know that you have to cut your diameter in half to get 6 to plug that in for the radius. Okay, but since they gave me diameter, I'm just going to use the formula with diameter. So just start substituting numbers in. So pi is 3.14, diameter was 12. So in my calculator, I'm just going to take 3.14 times 12, and we get 37.68. And this is circumference, so your unit is just going to be that centimeters. All right, number 9, find the surface area of the prism shown, and they do give us the formula. So our formula is SA equals 2 times LW plus LH plus WH. And then I can just start substituting my numbers in. So 10 is going to be our L, 8 is going to be our W, and 3 is going to be our height. So when I start plugging my numbers in, the 2 stays out front of the parentheses. LW means I'm multiplying these numbers. So L was 10 and W was 8. So I'm going to take 10 times 8 plus LH. So L was 10, H was 3. So 10 times 3 plus WH. So 8 times 3. Okay, then all we have to do now is just solve this. So you have to follow PEMDAS rules, so you have to do what's inside the parentheses first. And remember, you want to multiply before you start adding. So I'm going to come over here off to the side. So 2 is going to stay the same. 10 times 8 is 80, plus 10 times 3, which is 30, plus 8 times 3, which is 24. Now I can add these numbers together. So if I were to take 8 plus 30 plus 24, that gives me 134. And then your last step is to take that number times 2, and you would get a surface area of 268 centimeters squared. All right, moving on to the volume formula of a cylinder. So your volume formula is pi r squared h. And we are just going to start substituting our numbers in. So pi is always 3.14. R is radius, 14 is not the radius, 14 is the diameter. So remember, you have to cut it in half to get the radius, so half of 14 would be 7. H is your height of the cylinder, so in that case is 10. And then we can just start simplifying. So I have to take 7 squared first, which is 49, times my 3.14 times my 10. And I get an answer of 1,538.6. And this is volume, so it's going to be centimeters cubed. Volume is always cubed. Area is squared, volume is cubed. Alright, moving on to the next one. So they want us to find the mean for the given set of data and round to the nearest tenths. So remember, the mean just means you're taking the average. So all that you're doing is you're adding up all these numbers and then dividing it by how many you have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So I'm going to put that off to the side so I don't forget. Okay, so finding the mean, again, you're just adding up all the numbers. So 83 plus 97 plus 100 plus 81 plus 73 plus 84 plus 94 plus 91 plus 81. So that equals 784. And then again, mean is finding the average, so we need a number that's within the middle of the data. So 784 is not in the middle, but if you were to divide it by how many numbers there were, which is 9, you now get 87.1 repeating. So 87.1 repeating. If they want us to round to the nearest tenths, you're looking at the tenths place, looking at the number behind it. If it's 5 or greater, you are going to round up. If it's not, you're going to leave it alone. So in this case, we're going to leave it alone. So your answer, your mean, is 87.1. All right, number 12, find the median. So median means the middle number, but remember, to find the middle number, you have to first put these numbers in order from least to greatest. So the smallest number I see is 73. Then I have two 81s. Then I have a 83, an 84, a 91, 94, 97, and then 100. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have them all. Okay, so when you're finding the median, you're just taking your fingers and you're working your way in until you meet at one number, which in this case is 84. All right, moving on to a box and whisker plot. So number 13, what's the difference between the two heights median scores? So remember, your median in a box and whisker plot is the third dot, which is going to be the middle dot out of the 5. So it's within your box, so your median is that line. So when they're wanting to know what's the difference, you're just subtracting the two medians to figure out what is the difference between them. So as you can see, the girls' median height was at a 67, and the boys' median height was at a 66. So I'm just going to take 67 minus 66, and that gives me a difference of 1. Number 14, an outlier affects this measure of central tendency the most. So remember, your measures of central tendency are just mean and median. So when you have an outlier, so let's say I have some test scores. I have a couple hundreds, I have some 90s, I have some 80s, but let's say one student got a 20. So that student would be my outlier. And since they scored so low, what would that do to the mean or the median? Which one should it affect the most? Well, it's going to affect the mean the most because it's going to bring down the average by a lot. Or vice versa, let's say a lot of students failed, but I did have one student get 100. My one person that got 100 is the outlier, and they are going to bring up my median because they had a big outlier. So your outlier is always going to affect the mean the most, which means your best measure of central tendency for the set of data would then just be the median. If your outlier is going to affect the mean the most, you would then want the median to be the central tendency number that you want to look at. Okay. All All right, and then number 15, which box and whisker plot has more predictable heights? So remember, more predictable heights, you're looking for the smaller box. So which one has the smaller box? Well, the girls have the smaller box. So they have more predictable heights. And it's because, so your box is represented by your quartiles, and if you remember, we could find the range of it by taking the upper quartile minus the lower quartile. In other words, you're just finding the interquartile range. So the reason why it's more predictable is because 50% of your data is within your quartiles. So if you have a smaller box, that means it's more predictable to say what number it is. So when you guys explain it, I would just say that the girls had a smaller, and don't say box, let's use some mathematical terminology. The girls had a smaller, you could put IQR, or you can write out the interquartile range. Okay? Alright, so moving on to the back side. So the softball team needs to buy some new softballs for the start of their season. Each softball costs $5 and has a shipping fee of $12. If the softball team only has $137, how many softballs can they buy? Okay, so first thing we need to do is define the variable. So remember, defining the variable, you're just telling me what are you trying to find in the problem and setting that equal to your variable. So in this case, we're trying to find out how many softballs we need. So how about we have S equals number of softballs. Number of softballs. Okay, so now we can start setting up our equation. So the easiest number to find is always the total. So what number would represent the total? Well, they only have $137, so that is your total, equals 137. Okay, then the next easiest number to find is the number attached to the variable. So if we're trying to find out how many softballs, we need the cost per softball. So how much does it cost per softball? It costs $5. So that's going to be 5x. And then we have to include the shipping fee, which is going to be extra money. So we're just going to add it on. Okay, so now that we have our equation, let's solve it. So I'm going to move it over here. And then I'm just going to start solving. So first thing I'm going to move is that plus 12. So the opposite of adding 12 is subtracting 12. So we get 5x equals 125. And then our last step is to divide by that 5 on both sides. So 125 divided by 5 gives us, we can buy 25 softballs. All right, moving on to number 17. So Daniel had $25 to spend at the fair. If the admission to their fair is $4 and the rides cost $1.50 each, what's the greatest number of rides that Daniel can go on? So now we're not dealing with an equation anymore. We're dealing with an inequality because we're just trying to find out what's the greatest number of rides that he can go on. So let's first define our variable. So let's just have R this time equal the number of rides he can go on. Then we can start setting up our inequality. So again, always start with the total because that's the easiest to find. So in this case, he only has $25 to spend at the fair. So 25 is going to go here. But again, it's not going to be an equal sign. We need an inequality sign. So if he only has $25 to spend, can he go over 25? No, he only has 25. So you should have the less than symbol because your alligator mouth needs to be chomping up the 25. Could he spend all of his money though? Could he spend all 25? Yeah, if he has $25, he could spend it all. So you do need the equal to line. Okay, so now let's figure out where is our variable going to go. So if our variable is talking about the number of rides, we need the cost per ride. So it costs $1.50 per ride. And one thing I just realized, guys, up here for the softballs, I put our variable was S, but then I changed it to X. So I'm just going to change this back to an X. I should have used S since I put S to begin with, but since I messed up, I'm just going to change that back to an X. Okay, I did do it correctly here though. So R was number of rides and I put R as my variable. And then it also costs $4 to get into the fair, so that is an extra cost that we need to account for. Okay, so I have my inequality, so let's solve. So I have 150R plus 4 is less than or equal to 25. So first step to get R by itself is to subtract that 4 on both sides. So I'm left with 150R is less than or equal to 21. And then our last step to get R by itself is to divide by that 150. And we get R is less than or equal to 21 divided by 150 is 14 rides. So using words and or numbers, interpret your solution. So what we're looking for when you guys are interpreting your solution is not telling us he can go on 14 rides. Okay, because he doesn't have to go on 14 rides. He could go on less than 14 rides too and still have money left over. So what we're looking for is for you guys to say he can go on at most, because he cannot go over that, 14 rides. So this is the word that we're really looking for. So we're looking for the inequality word within your solution. Okay, so he can go on at most 14 rides. So don't put he can go on 14 rides. He could go on at most 14 rides. Alright guys, then the last question, given the circumference of the basketball, that is 31.4 inches, find the area of the basketball and to show all of your work. So remember, when you are going from circumference to area, there is one thing in common with both of your formulas, besides pi. We're not going to use pi because that's just a number. One thing that's in common though is the radius. So to go from circumference to area, you have to first stop in the middle and find the radius, because that is what's going to help us. Okay, so if they give you circumference, start with the circumference formula. That's 2 pi r, and then just start substituting numbers in. So C stands for circumference. They told us that the circumference was 31.4, so I'm going to plug in 31.4 in for C. 2, drop down the 2. Pi is 3.14. And then again, to get from circumference to area, I need to find the radius. So R is just going to stay R right now. Okay, and now I'm just going to solve it. So I can see that I can simplify 2 and 3.14. So if I were to multiply 2 times 3.14, that would give me 6.28. And then our last step to get R by itself, since the 6.28 and the R are multiplying, the opposite of multiplying is dividing. So then our radius is going to be 31.4 divided by 6.28. So our radius is 5. Okay, so we went from circumference of 31.4 to a radius of 5. So now I'm going to use that radius to find the area. So our area formula is pi r squared. Pi again is 3.14. We just found the radius to be 5, so we're going to plug in 5 for radius. And then now we're just going to simplify. So 5 squared is 25. 25 times 3.14 gives us an area of 78.5 inches squared. And that is it. So this is what your guys' final looks like. So use this to help you guys, and then let us know if you guys have any questions.